Hello, I'm Emanuela Marsh, and this is my Lab 2 for Physics 2112, where we looked at some of the interactions between charges distributed over a line. So some of the important concepts that we used again in this lab were the electric force between two charges based on Coulomb's law, then the concept of electric field, and then also gravitational force, which have all these equations here. And something new that we used was the derivation for the electric field due to a charge along a line and how this affects something perpendicular to it, which is based on the last integral. So the model for this lab was the same as for the first one, where we had two charged pieces of tape that we made from tearing them apart, and this would transfer charges between the tapes, and then we measured the distance between the two tapes at which they repelled each other. And we made some assumptions from this to simplify our calculations, and we ignored air resistance on moving object on the tape that was moving and being repelled, and we also assumed that both of the U-tapes that we used had about the same charge and that this was evenly distributed, which came into play when we separated the charge along the line into pieces. So from lab 1, we did a very simple calculation where we treated the tape as a point charge and set the electric force equal to the force of gravity, and we used that to calculate the magnitude of the charge, which was about 2.13 times 10 to the negative 8th coulombs. So for our calculations this time, we removed the assumption that the tape could be treated as a point charge and instead treated it as evenly distributed charges along the line, and I used 10 equally charged sections, and then we used that integral calculation that we saw earlier to calculate the charge on each of those sections and the electric field and the force from that. And you can see that those are what the green lines represent. It's the electric field coming from the bottom tape up towards the top tape, and then the white arrow represents the electric force when we represented this as 10 charges on each of the tapes, and the yellow arrow represents the gravitational force acting on the center of mass of that tape. So when we set these equal to each other, we found that the charge on the tape was closer to 3.7 times 10 to the negative 8th coulombs, and